Hello everyone, today we are going to discuss the Bodo plot. So the procedure steps to sketch the Bodo plot. The first step is express the given g of s into h of s into time constant form. So time constant form means you have to convert it into standard time constant form. So let us, if we are consider the equation that is g of s into h of s is equal to k divided by s into s plus 2 into s plus 4. So this is the given equation. How to convert this into standard form means take the constant term as outside, that we can call it as the conversion of given expression into standard time constant form. So this, which 4 is the common, 1 plus s by 4. So if we are multiplied this, we will get back the same equation. So 4 plus s. Okay, so this is the standard time constant form, that is k divided by 1 plus t1s into 1 plus t2s, that is called as standard time constant form. Then the second point, draw the line 20 log k dB. So that will be discussed in the problem. Draw the line appropriate slope representing the poles or zeros at the origin passing through the intersection point at omega is equal to 1 in 0 dB. So 1 in 0 dB means while sketching the Bodo plot, we are considering an slope, that is magnitude plot. This is 0 dB line. This is the point O. Then you have to mark minus 20 dB, minus 40, minus 60 dB. So this is omega is equal to 1 at 0 dB line. Just for reference of slope, you can draw the dotted line from corresponding gain, that is minus 20 to this point. So join all the slope line 1, 2, 3, minus 80 means you can join to this point only. That is the step number 3 denotes. Then step number 4, what it says, shift this intersection point on 20 log k line and draw the parallel line to the line drawn in step 3. So that will be also shown, you can observe in the problem. And this addition of constant k and number of poles or zeros at the origin. So then change the slope of the line at the various corner frequency, and you have to, depending upon factor, the corner frequency for simple pole is minus 20 dB per decade. If it is for poles, for any given problem having the poles, if it is one pole at origin means the slope will be start from minus 20 dB per decade. Clear? If it is zeros, 1 zeros at origin, then slope will start from plus 20 dB per decade. These 2 points we are keep it in mind. Okay. So then do not draw the, change the slope of line obtained from step by 5 by respective value and draw the line with resultant slope. Then the last point is steps is prepare and phase angle table and obtain the table of omega and resultant phase angle pi r by actual calculation. That also we can observe in the while solving of problem. These are all the basic fundamental steps to sketch the Bodo plot. Let us now discuss with the first problem, that is the problem number 1. Discuss with the first problem. So we have to observe here problem number 1. A unity feedback control system has g of s. So unity feedback means the value of h of s which is equal to 1. So g of s is 80 divided by s into s plus 2, s plus 20. Draw the Bodo plot, determine gain margin, phase margin, omega gc and omega pc. So now we have to solve the problem. First we have to convert the given problem into standard time constant form. So let us rewrite the given problem g of s into h of s as it is 80 divided by s into s plus 2, s plus 20. Then convert to standard time constant form. If I convert to standard time constant form, you will get 80 divided by, here take 2 is the common factor. So just observe here, and 20 is the common factor from the second term. So then you will get, so 2 divided by 1 plus s by 2 into 1 plus s by 20. Then step 2, identify the factor. So identify the factor means if you compare with this equation with standard equation, that is k divided by 1 plus t1s into 1 plus t2 into s. Here the value of t1 is 1 by 2 and value of t2 is 1 by 20. So in numerator k is directly equal to 2, that is 1 by s, 1 pole at origin. Okay, that is 1 pole at origin means the slope will start from minus 20 dB per decade. Then 1 over 1 plus s by 2. So from this factor, if you compare with standard time constant form, we will get t1 equal to 1 by 2. Clear? Then if you are converted into frequency, omega equal to 1 by t1, so we will get 2. Similarly, the next factor is 1 over 1 plus s by 20. So if you are compare with t2, 1 by 20, then omega c2 is equal to 1 by t2, that equal to 20. So then step 3, magnitude plot analysis. To find the magnitude plot values, consider k value, k equal to 20. So if it is k equal to 20, then you can use 20 log k, that is equal to 20 log 2. So we will get the 6 dB. Then magnitude plot analysis means you have to use this equation like this. So write the factors, then frequency, then slope. So here the factor is the first factor 1 by s. So there is no frequency because it is 1 pole at origin and the slope magnitude is minus 20 dB per decade. Then the second factor 1 over 1 plus s by 2. Then omega c2 is known, that is 2. Slope is for first 1 pole at origin, magnitude is minus 20 dB. If you consider the next pole, that is in denominator, that is nothing but you have to add again the slope value minus 20 dB. Initial slope is minus 20. If you are adding the again minus magnitude slope minus 20 dB per decade for the second factor, the total magnitude slope is minus 40. Then consider the next one, third factor. This is the frequency. So minus 40, minus 20. Each factor, if it is present in denominator, then you have to add minus 20 dB per decade for each slope line. If it is in numerator, you can add plus 20 dB per decade for each factors. So that's why you have to rewrite the tabular column in this form. So we will get 60 dB. Then the last step, that is a step number 4. To plot the phase angle plot, convert the phase angle plot. So replace s by j omega. So replace wherever s is there, just look at here, you have to replace it by j omega, 2 divided by j omega. So j omega, j omega. So then you have to apply the angle condition, angle of, okay. So if you apply the angle to any constant term, its angle is 0. Then consider the first term 1 over 1 by j omega. Angle of j omega is, we know that it is 90 degree. If you are shifted to numerator, it become minus 90. So then consider the second factor 1 over 1 plus j omega by 2. So this is in the form of x plus iy. We can use the trigonometric relation, it is minus tan inverse of omega by 2. So then for the next factor, minus tan inverse omega by 20. Then here we have to calculate corresponding corner frequency and phase angle. So let us start with the point 1 or point 2. So there is no particular rules. So let us select any value, point 2. First factor, then second factor, third factor, add pi r. Pi r is resultant of all these values. So you can add all these values, you will get this plus minus 90, minus 5.7, minus 0.57, you will get minus 96.2. So vary the omega value from 0.1 to infinity. In between these two values, have to select a corner frequency. Our first corner frequency is 2 and the next corner frequency is 20. Between 2 to 20, we can select either 1 or 2 values because we can identify where exactly the slope will be meets magnitude plot, or else in the phase angle plot, slope where exactly meets 180 degree line. So this is j omega. So this is the complete table. Okay, 1 by j omega means it is default value minus 90. Put omega is equal to 0.2 here, we will get the angle. Here also put omega equal to 0.2 by 20, we will get the values, and this is pi r. Finally, you have to sketch the root locus, that is Bodo plot with the help of all these values. So first we have to draw the line. So just observe here and draw the line. So take the semi-log graph sheet. So you can draw the Bodo plot using semi-log graph sheet. Semi-log graph. So first draw the vertical axis, then draw the horizontal axis. So the semi-log graph sheet is divided into two portions. One is for magnitude plot and one is for phase angle plot. So mark the values. So in the x-axis, common frequency. So this is 10 Hz, 100 Hz, 1K, 10K, 100K, okay, and so on. Same frequency also here, okay. So then in this you can mark here omega is equal to 1 at 0 dB line. So in the phase angle plot, you have to draw the minus 180 degree slope line, that is degree. Clear? So you can draw this line and here you can draw the slope line. Then you can mark the some values, that is this is minus 20 dB, minus 40, minus 60. Draw in dotted lines, okay. Clear? So then here we will get to minus 150, minus 120, minus 90. Here minus 210, 240, 270, and so on. Here plus 20, plus 40. So we are drawing the line. Then, so in the problem we will get the magnitude plot. 20 log k is equal to some values, that is 2. K is equal to, you will get the magnitude slope, that is 6 dB per decade. Draw the line, that is 6 dB per decade here, okay. I will draw the 6 dB per decade line. Clear? Then first select the first slope. What is the first corner frequency? Omega C1 is equal to 2, and second corner frequency is, that is 20, and up to infinity. Select the first corner frequency, that is 2, okay. So here somewhere here we will get the 2 corner frequency. Draw the slope line, which is parallel to 20 dB per decade. So we will draw the slope line which is parallel to 20 dB, and that slope line which crosses a point of 6 dB, that is magnitude point will be crosses with each other, or else we can draw like this. Draw the slope line which is meets the first corner frequency, that is omega is equal to 2. Clear? So I will explain in the graph after look at the graph. Then we have to draw the next corner frequency, that is 20, then infinity. Then from the readings I have to draw the phase angle plot. How the graph will be appear? By look at this problem. So the graph will be appearing like this. This is the first plot we have drawn here. So look at the graph carefully. Clear? So look at here. So that is the 0 dB. What I told as similar procedure, here we have drawn the graph. This is 0 dB. Mark the points, minus 20 dB, minus 40, minus 60. But as usual we have to values in upper quadrant, it is positive. But actual as for the procedure, this is slope line will be different. And here minus 20, minus 40, minus 60, and so on. So then you have to draw the 20 log k slope line. Have you observed this 20 log k? So that will be drawn. Then here you can mark the phase angle magnitude plot, that is phase angle plot, 180 degree slope line, you can draw it. And the frequency in the top corner we are observing, these are all the frequencies. Clear? So then the first value, so just have to mark the points, omega 1 equal to 1 at 0 dB. Then you can just project it towards magnitude slope, that is 20 log k. Draw the line at omega is equal to 2, which is parallel to this 20 dB. Whatever you have to draw on the slope, this slope is parallel to 20 dB per decade lines. Just observe here, if you move the scale parallel to this, okay, then select the next corner frequency, that is 20. This, from this omega is equal to 2 to 20, whatever you have to draw in the slope, this slope is parallel to minus 40 dB per decade. So if you are moving the scale like this, then from 20 to infinity, which is parallel to 60 dB per decade slope line. So just you have to move the scale like this, you will get the values. So then phase angle plot, you can use the frequency versus pi r. You have to mark the lines, you will get the values. There is no difficulties. Okay. Then from the graph we can observe that where phase angle plot crosses 180 degree, mark this point and project the line towards phase angle magnitude plot. Phase angle plot where it crosses 180 degree, consider that point, projected lines towards magnitude plot. There you will get gain margin. Then observe the phase angle magnitude plot where it crosses 0 dB, mark that point, project it towards phase angle. So that gives, we will get the phase margin. So that is the measuring of phase margin and gain margin. And if you are projected towards an x-axis, you will get the phase crossover frequency, that is omega pc, and gain crossover frequency, that is omega gc. So gain crossover frequency with respect to phase margin and phase crossover frequency with respect to gain margin. This is about the complete Bodeau plot problems. Clear?